Hello everyone, welcome back to our channel. Let's discuss the next topic, that is proton exchanges in proton NMR. Okay, suppose you have a alcohol molecule. Let's take 1 ml of alcohol, right? The alcohol containing two molecules. Assume, hypothetically, assume two alcohol molecules are present in one sample of alcohol, right? So in such cases, what happens? Whatever the heteroatom proton we are having, these two protons are always exchanges to each other. So this will come here, this will come here. Why? Because alkoxide ions are more stable or not. RO minus and H plus. So the exchange of the proton takes place. That is commonly called as proton exchange. Mutual exchange of protons on the heteroatom among the molecules are commonly called as proton exchanges. Exchange of one proton by the another proton in a sample. So this kind of situation is possible in alcohols, acids and amines. Okay. The rate of proton exchange depending upon the following factors: purity of the sample, temperature and polarity of the sample. Let's see the first one. Purity. Presence of impurities increases the proton exchanges. It means whenever you take the impure sample for the analysis, what happens in those cases? Proton exchanges are higher. Second one, the increasing the temperature, the rate of proton exchange is also increases. Why? Because ionization phenomena increases. Alcohols, acids, thiols are easily going to be ionized, so it can easily produce as the H plus ions. So H plus ions can be easily replaced. So by increasing the temperature, proton exchange is going to be increased. Next, polarity of solvent. If you use non-polar solvent and polar solvent, what happens? You have the sample. The sample is taken in the deuterated one and more polar one. This is the non-polar, this one is the polar. In case of the polar, what is happening? Hydrogen bonding is developing. In case of the non-polar, what is happening? There is no hydrogen bonding. If in case hydrogen bonding is there, weak hydrogen bonding is going to be done. If it is the strong in nature, hydrogen bonding is strong in nature. Is it possible this proton can be easily replaced with another proton? It is not possible. It means whenever you use the more polar solvent, strong hydrogen bonding phenomena takes place. That's why proton exchange will be lesser. Okay, see this. In polar solvents, rate of proton exchange is slow due to strong attractive interactions between the heteroatom protons and the solvents. DMSO is more polar than CD2Cl2. In DMSO, proton exchanges are slow than in CD2Cl2. So, in case of the non-polar solvents, proton exchanges are higher. In case of the polar solvents, proton exchanges are lower because of the presence of hydrogen bonding. So, these are the three factors generally we will say. What is the first factor? Impurity of the sample. If you have the impurity, proton exchange increases. If you increase the temperature, proton exchange increases. If you use the polar solvent, proton exchange decreases. Clear? Then the question is, what is the effect of proton exchange in the proton NMR spectra of chemical systems? How the proton exchange phenomena is going to affect on the proton NMR signal, that we need to discuss. That is effect of proton NMR signal, effect of proton exchanges on proton NMR signal. Okay, suppose let's take one molecule, that is methanol. What the people are saying? Impure sample. Because of the impure sample, people are saying no coupling. Here, pure sample, coupling. Here, see this, the spectra. The spectra is something different or not? What the people are saying, we have the methanol. Assume that we have a methanol sample. In the methanol, what happens? Assume two methanol molecules are there. So CH3OH plus CH3OH. So impurity is there. That's why what happens? This H is replaced with the H of the second methanol molecule. So this is the continuous phenomena. Continuously, this proton is replaced by the proton of the second alcohol molecule. Thereby what happens? These three protons cannot recognize the OH proton. That's why there is no coupling between these three protons and the OH proton. That's why it will appear as single and it will appear as single. But if you take pure sample, what happens? There is no chance of the proton exchange. No proton exchange. No proton exchange means this proton is always available to interact with these three protons. So according to n plus 1 rule, this proton will give the doublet to this one. According to n plus 1 rule, these three protons, 3 plus 1 means 4, means that is what? Quartet to this proton. That's why the OH appeared as a quartet and the CH3 appeared as a doublet. So whenever you take the pure sample, proton exchange phenomena is not possible. Because of the non-possibility of the proton exchange, the coupling phenomena takes place. N plus 1 rule we can follow. Thereby we will identify the different kinds of signals. Similarly, in case of impure sample, what is happening? These two protons are always exchanging with the two protons of the second molecule. That's why what happens? These three protons will not recognize the NH2 protons. That's why no coupling. So single protons we will get. In case of pure, coupling phenomena takes place. 2 plus 1 means what? 3. That is triplet you can observe. Here you will get the triplet. 3 plus 1 means here you will get the quadret. In this way, the proton exchange is going to affect the NMR spectra. So, in generally, the conclusion is what? Whatever the samples we are getting generally for the commercial purpose, all are the impure samples. So, impure sample means what? We can consider the proton exchange higher. That's why there is no coupling on the heteroatom proton. That's why always whenever you see the problems, that people will not consider the coupling between the heteroatom proton and the carbon protons. We will neglect this one. Why? Because we are assuming that our sample is impure. So in case of the impure, what is happening? Proton exchange phenomena takes place. That's why there is no coupling between the protons. So simply assume that whatever the samples which we are getting, the samples are impure in nature. That's why always COOH is appeared as a singlet and this one will appear as a singlet. If you consider pure, then only we will come up with some. Okay. So in case of the acid, what we are observing, the distance is very far. That's why in case of pure also here we are getting the singlets only. So mainly the discussion with the alcohols and the amides. Okay. So in case of the pure sample, what the people are saying again, stepwise n plus 1 rule will be followed. Okay. In case of the pure sample, the CH2 will interact with OH protons and the CH2 will interact with CH3 protons also. That's why we need to follow stepwise n plus 1 rule. So according to stepwise n plus 1 rule, we will get C. The OH will give doublet to this one, right? Initially. This one, it can give quadret. Okay. In this way, we can identify the peak. See this one. CH2, how many lines we are getting finally? 8 lines. OH 3 lines. 2 plus 1, 3. 2 plus 1, 3. So 4 plus 3 plus 1, 4 and this one. So stepwise n plus 1 rule we are following. That's why we come up with the 8. Initially 3 plus 1 4 na. See 1 2 3 4 4 lines, right? Again stepwise it will give doublet na. So doublet. So 4 into 2 is going to be 8. That's why 8 lines we are observing in case of the ethyl alcohol. So in this way the proton exchange is going to affect the signal of NMR. Okay, here you have three problems. See this one, it is the molecular formula, that this is the data. One proton triplet, two proton doublet, what will be the combination? One proton triplet you need, one proton means that will become CH, right? What you need? Triplet you need. Here you need triplet na, here you need triplet. So if you want to get triplet here, if you want to get triplet here, adjacent protons must be how many? Triplet means 3 lines na. So in order to get 3 lines, adjacent how many protons you should have? 2 protons only. So how can you write 2 protons? CH2. See this one. These 2 protons giving triplet to this one. This 1 proton giving doublet. N plus 1 rule. 1 proton means 1 plus 1 means what? Doublet. Triplet by doublet. So what is the skeleton? CH2CH. So balance the carbon valency by using the chlorines. 5 chlorines na. Balance it. And 3 carbons here. Here you have 2 carbons. So you need to put 1 more carbon. So balance the valency. So all will be chlorines. Here 1 more chlorine. Here 1 more. So thereby you will get the molecule. Similarly, 6 proton doublet, 1 proton multiplet. Okay. And how many carbons are there? 4 carbon. How can you write 6 proton doublet? It is not possible. Or possible? Yes, possible. You can write in this way. See this. CH3, CH3, CH. This is one proton. Na? All 6 protons are chemically equivalent or not? So because of this one proton, all 6 protons will become doublet. So all the 6 protons are giving what? Septet or not? 6 plus 1 means 7. But adjacent you have what? CH2. One more 2 proton doublet. 2 proton doublet means adjacent you should have only 1 proton. So CH2. So this proton is giving doublet to this one. Now these 2 protons are giving triplet. So septet by the 6 protons are giving septet. How can we write it? Is 6 protons are giving the septet and 2 protons are giving the triplet. So septet by triplet is commonly called as what? Multiplet. Multiplet means what? Merging of signals. Doublet by doublet, doublet by triplet, triplet by doublet. Right? In this way, that is commonly called as multiplet. So in this way, you can simply identify the structure of the compound. Okay. So these are some of the examples which are related to the NMR. Right? In the next video, we will be having a discussion on deuteriations in proton NMR. Okay. Thank you.